previous chips have been implemented using combinational logic. And with combinational logic, the output is purely a function of the inputs. However, combinational logic chips cannot maintain state. So if the inputs change, the output will change it. Like the chip cannot remember what the kind of current output state is. So in order to store and recall data, we actually need to build memory. And we build memory using sequential logic. Now with sequential logic, the output depends on both the input, just like combinational logic, but it also depends on the current state. And also sequential logic circuits have this notion of time, and so we introduce a clock to keep track of the circuit behavior. So now look at the differences between combinational logic and sequential logic. So we know combinational logic is essentially made up of logic gates, but now the key component of sequential logic is a flip-flop. So sequential logic also always contains some sort of feedback loop. So we can see on this picture here, we've got a combinational chip. So this could be an AND gate or an OR gate or whatever. So we know we've got our, say, two inputs, a logic gate and then a single output. But here, with a sequential chip, so you can see the sequential chip includes some flip-flops. It may also have some combinational circuits either before or after the flip-flops, but there's always this form of feedback. So the output feeds back into the input as well. So now the output is some function of the input in the previous time step and also the output in the previous time step. Where with a combinational chip, we know that the output, there's no notion of time, the inputs change, the output will change. Well, there's some small propagation delay, but essentially the input changes and the output changes straight away. So with sequential circuits, we have a clock signal. So this clock signal is a periodic waveform. So typically it's kind of this on-off type signal, so a square wave. And the period of this clock cycle is determined by the clock frequency. So it's just, the clock frequency is 1 over this period. So here, on this waveform here, we know that the period is just for one complete cycle. So there's two parts to it. We've got a tick part, so when the clock signal is low, we'll call that tick. And then when the clock signal is high, we'll call it a tock. So the clock is made up by this tick-tock, tick-tock, tick-tock. So each cycle is made up of a tick and a tock. So during this tick-tock cycle, so any point within a cycle, at any point in time between here, the internal states of all the clock chips can change, so inputs can change and so on, but nothing will actually update if you. So the outputs are latched. So during this point, during this time period, the inputs can change at any time, but the output will only update. So the output only changes at the end of this cycle. So we've got a tick and a tock. So at the end of all these essentially these falling edges here, at the end of every cycle, and if any change to the inputs has occurred during that cycle, the output will update. So that means throughout your circuit, you can have multiple sequential chips. The inputs can change at slightly different times, but the outputs of all the chips that share that clock signal will only update at the end of this cycle. So this keeps all the chips in this circuit synchronized.